Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are soaring to new heights live at Franklin Elementary School, home of the Falcons, where the sky's the limit. And today we're all here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Susie. And if you want help with your math, you can call here in Bakersfield 636-4357. If you're in San Luis Obispo or other outlying areas, call toll-free 1-866-636-6284. You can also email us at dothemath@kern.org. And you can watch online at dothemathonline.net.
All right, well, you know what? Happy Halloween.
You too.
Today is indeed Halloween, and we have a very special guest in the studio. We'll be going out to visit Devin in a little while, but before we get to other things, a reminder for the 5th grade students that the month of November, and we're going to start it today, is the 5th grade call-in contest. So if you're a student and you are viewing the program and you need a little bit of help, especially if you're in 5th grade, when you phone in, you want to let us know that you're in 5th grade and who your homeroom instructor is, right? And then the classroom that calls in the most during the month of November will come out with a bunch of prizes and things during the month of December to award you guys and film you guys and do some cool stuff while we're out there.
Did you know that my class won that?
You guys won that one time?
About 10 years ago, and that's the first time I was on the show.
There you go. That long time ago, huh?
Yeah.
All right, before we get to the phone calls and all of the other activities of the day, let's first take a look at today's Math in the News. All right, well, today's Math in the News, obviously we're going to do a little something with Halloween, pumpkins, because one of our producers beautifully decorated our setup here with some pumpkins and a stray bat in there. And so we'll take a look at some pumpkin facts. What state do you think produces the most pumpkins in the United States?
I'm going to go with California.
California is in there,
Okay.
but it's not the top one. Illinois produces 1.5 billion pounds of pumpkins in the United States.
Wow.
Okay, that's half of all the pumpkins. All right, so the other states, Michigan, New York, Ohio, Pennsylvania, and California, don't even produce as much as Illinois. I found that hard to believe.
Yeah, because I've been to Illinois and I saw a lot of cornfields.
Well, they grow a lot of stuff there now. There are a lot of pumpkins there. The Great Pumpkin, the Peanuts, Charlie Brown thing, 7 million viewers a year. Still, I think that thing came out when I was like in diapers, and that. So, anyway, nice to see that the Great Pumpkin is still going. We have a few more facts that we'll share throughout the afternoon. But first, pumpkin seeds. Do you love them or hate them?
I like them.
You like them. You don't love them.
Yeah.
So you like them once a year, or is it something that you would have more often if they were around more often?
Once a year.
Once a year, all right. And is there a particular spice you would throw on those?
Seasoned salt.
Seasoned salt? I was just telling somebody was wondering if it might have been cinnamon or something on there. I was saying I would put cayenne pepper on those. That'd spice it right up. Anyway, dealing with pumpkins, those seeds come from vomiting pumpkins. So that's where they come from.
Okay.
Or you can just cut them out the other way. But a lot of people doing jack-o'-lanterns and get quite creative
Yes.
with the designs on these pumpkins. Pumpkin paddling. So this, I know, takes place in Oregon, one place, and I think they have probably some other spots, but you need a rather large gourd to
Yes.
be able to hollow that thing out and then be able to get in that thing. Would you do that?
I think I would.
I would too. Why not?
Yeah.
Pumpkin paddling. How about this?
What are they doing?
Pumpkin chunking. They're going to put it, and then they're going to like catapult these things out of here.
Well, that would be fun.
So for distance. And so another activity right there. Why not carve it while you're underwater, right? Just a different way of doing it. Pumpkin drop. We all know about the egg drops that students do in classes and some science things. And so anyway, they do have an official pumpkin drop. And we might as well get to a little bit of math behind the pumpkins.
Sure.
90% water. Pumpkin pie. Do you eat pumpkin pie?
I do.
Mackenzie eats a lot of pumpkin pie.
Does she?
I dare say she could wolf down 2 pumpkin pies at a sitting if she needed to. But anyway, the largest pumpkin pie ever made was over 5 feet in diameter, weighed over 350 pounds. 80 pounds of cooked pumpkin, 36 pounds of sugar, 12 dozen eggs, and took 6 hours to bake. So a
Where
little
would
bit
you
of,
bake that?
yeah, you're going to need something pretty big to put that pie in. And anyway, that is today's Math in the News and some of the numbers behind it right there. And our lovely little Halloween set right there. Once again, we do have phone tutors available on Tuesdays and Wednesdays between now and 5:30 throughout most of the school year. In studio with us once again, we have Thomas. How are you today?
Hello.
Why don't you remind everybody where you go to school and what grade you're in?
Hart Elementary, and I am in 5th grade.
And you're in 5th grade. So since we saw you a couple weeks ago, right? Everything's still going smooth at school?
Yeah.
Anything difficult, let's say, as far as the math is concerned? Or is it all pretty smooth so far?
I'm definitely going to need a little help with fractions. I kind of failed the test.
Well, you know what? That's exactly why we're here. We'll work on some fractions. Adding, subtracting, multiplying, what are you doing with them right now? Comparing them, what kinds of things are you doing with fractions?
Multiplying like 2 fractions. That's pretty easy, but
All right, well, you know
Mixed
what?
numbers?
We've got a couple of moments
Yeah.
before we head on out to, so let's go on over to the board and we'll just work on some fractions right now. Susie will be right there with you. So Susie, how about if you come up with the first fraction?
Okay.
So you can come up with one and then Thomas will come up with the next one.
And are we going to multiply? Okay.
Well, the kind of pen that you had makes that dashed line right there.
oh,
The one that you chose. That's all right, you should be able to do it now,
Yeah.
so.
Okay. Are you
I
going
shouldn't have
to?
chose this.
Well, do you want to cancel or do you just want to simplify later?
But
I'm going to give you a little hint. Those 2 won't cancel. So let's erase those, okay? But these 2 will cancel. Do you know how many times 3 goes into 12? That's right. And so then that turns into a, yeah, you already know. Okay, now it's an easy problem.
I'm just gonna read it.
Is it because we're both using pens at the same time? There. Okay. So now you have 1 times 7. Yep, you did it. And I don't let my students forget equal signs. How about that? Okay, we did it.
There you go, nicely done. So I know that something that's going to be coming up for Thomas in 5th grade will be multiplying decimals, so we'll do a little bit of that later on. Just a reminder, we do have phone tutors available until 5:30 this afternoon. 636-4357 is that phone number, and some sound effect I heard in the background there. Was that something on purpose, I take it? Maybe not? Yeah, hooray, why not? All right, then we'll get rid of that. There we go. Anyway, just a reminder also, we do have the 5th grade call-in contest. We're going to go ahead and start that today, even though it officially says November 1st through the end of the month. Since today is October 31st, and we're starting the week today. We will go ahead and start that today for the 5th grade calling contest. We'll get to our first phone caller in a little while, but right now we're going to head out live to Franklin and visit with Devin.
Hey, thanks a lot, Mike. Back here at Franklin Elementary School on this Halloween night. I can't say Halloween night yet, right? Maybe if you're viewing us from the East Coast, you're deep in the thick of this. You can watch, however, on YouTube. If you're watching us on YouTube while you're trick-or-treating, I commend your commitment to our program, ladies and gentlemen. But we're here at Franklin, and we're talking a lot about place value today. Joining me right now is Larry. Larry, how's it going? This guy is ready to go right now. Has anybody tried to put a candle inside of your chest?
No.
Oh, thank goodness. That would be very painful. So Larry and I are going to be walking around helping out some of his colleagues here at Franklin Elementary with place value. So what we've been doing is we've been building models of place value tables. And we've been talking about ways to make sense of place values. This group over here did a great job of laying this out. We talked about the idea that a lot of times when we write the place values, it's with a representation, like a letter, like an O for ones, a T for tens, H for hundreds. And that can be kind of confusing once you get to thousands and 10,000s and 100,000, a lot of T's and H's. So writing out the name could be very helpful, but also writing out the multiplier for each place value is helpful too, because this shows us that if we have a number down here, this tells us how many of each place value exists in a number. So if we write 4 under thousands, we're saying that that's 4 times 1,000, or 4 thousands, or 4,000. So what we're going to do with that is explore a little bit about the different ways in which we can play around with the place value table. So, for example, Larry and I were talking about ways to make sense of 100. And we could put 1 under 100 and then 0 under the rest of the place values to show that we have 100 and 0 of the other place values. But then Larry and I talked about something really interesting, is how could we show 100 by putting some different values in some of these columns? So, Larry, what was a number that we talked about that we could put in a different column to represent 100 differently?
10.
So we put a 10 in which column?
The tens.
So we put a 10 in the tens place. And I'm looking at the people in the room right now, and they are furious. They think that we're violating the rules of the place value table. You can only put a single digit in there. But no, we can put multiple digit values in here, because what does this really mean, Larry?
It means
So when we put 10 in this value, how many tens do we have?
10.
Tens. So what we're saying is that there's 10 tens in 100, right? That's what 100 is. It's a group of 10 tens. So how many ones do we have in this right now? We have 10 tens. How many ones do we have?
10. Wait. 10.
Well, we already have 100, so how many ones do we need to get to 100?
100.
So we have 100. We're going to presume that that's 100 thanks to the smartboard. We're saying that 100 is 100 or 10 tens or 100 ones. So our challenge to the students here at Franklin today is to use the same idea and go big. So our challenge right now is we're going to challenge all of our groups here to do the same thing with 1 million. We're going to be talking a lot about the number 1 million today. It's our favorite big number. Whenever we want to say I have a lot of things, I say I have 1 million things. Do I have 1 million things? I wish, but no. So we're going to talk a lot about what 1 million really means. So your challenge, and Larry, you and I are going to kind of walk around and see what people are doing, is to use the place value table to show as many different ways to show 1 million. Are you ready? Are you ready? Let's do it. 3, 2, 1, go.
Put a 1 and then a 0 and the rest. Yeah.
And then see this group starting off
Wait,
good.
you do 1. Now you do. They're putting the 1 in the millions place. You put 10 right there. And then they're putting 0. And then you put
Okay.
the rest.
So now they just put a 10 in the 100,000s place. What does that mean
the rest
about
right
1
here.
million?
On this.
That it
Put
has
0
what?
right here. Yeah, 0. That would be.
It has 10.
That would be 10
Yeah, 10 100,000s, right? 10 100,000s in 1 million. And so it's going to be really interesting to see how we play around with this, because there are a lot of different groupings that you can make to break this down a little further. Let's see what we have with some of our other groups here. Let's look over here. So as we write down the place values here, you guys organize this very interestingly. Normally, the place value table starts with the lower place values on the right? Like the ones would go here and the tens would go here. But you started with the ones over on this side. Now, are you still going to be able to represent 1 million using just place values with this structure?
Yes.
I think so. So we'll check back with you guys and see how you approach them. Okay? What's your question? How do you spell 1,000? Do you want to help her out with that? You know, it starts off with a TH. And then how do you say ow? You got it. And now over here, we have our place value set. And you started playing around with the 100, right? We have 10 tens to make 100. Now, if we do that with 1 million, what do you think would be the best place to start?
I would think if we are doing the millions, then I think we would have to start with the
So
and start with the ones and start going on to the millions.
So go ahead and start that off. We're going to check back with all the folks here. Larry's been a great help with getting us started with this activity. And when we come back, we're going to start designing. We're going to come up with a plan to show you at home what 1 million really looks like in the world. But for now, we're going to go back to the studio. Mike, take it away.
All right, thanks for that, Devin. I'm sure a lot of kids are looking forward to maybe getting 1 million pieces of candy tonight as they go out on Halloween this evening. 636-4357 is the phone number. We do have phone tutors available until 5:30. We're going to go to the phones right now. And a repeat caller, I do believe, is on. How are you tonight?
Good.
All right, and you are a 6th grade student, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay, so the math problem I'm working on is an algebraic expression, and it goes as the following. 2.3n minus 3.2 plus 4.1 equals negative 6.
Equals negative 6?
Yes.
Okay. So we're correcting this, right?
Yes.
Okay, what do you think we should do first?
Since there's no other there's no other numbers with an n after it, so 2.3n would come down.
Just a
Oh,
second.
hold
I
on a
lost
second.
the
Let me get it
problem.
all back there for you. There you go.
Oh, okay, thank you. Okay, say that again.
So since there's no other number with an n after it, we would bring down the 2.3n.
Okay.
And then it would be, and then negative 3.2 and plus 4.1 can, so then we would combine alike terms, and we would do negative 3.2 plus 4.1. And when you, and since it's a positive and negative, that means we're going to subtract.
That's correct.
So then our answer is going to be 0.9.
I agree.
0.9.
And how about the right side of the equation?
What?
The right side of the equation?
The right side of the equation, then it would be equals negative 6.
I agree. Okay, you're doing great. What do you think comes next?
So we're going to cancel out the positive 0.9. So in order to cancel it out, we would put negative 0.9, and we would cancel that out.
Great.
And since we did it on one side, we also have to do it on the other side of the equal sign.
That's excellent.
And since there's a negative and a negative, that means we're going to add. So then it's going to be negative 6.9, and then on the other side it will be 2.3n.
And I'm going to move this down a little for you, Susie, so you
Okay.
have a little more room there.
Thank you. You're doing great. I agree with everything you're doing.
Okay. And for 2.3n, we're going to divide that by 2.3, which would cancel out, and we would have n equals towards our answer, and then we would have to divide negative 6.9 by 2.3.
I agree.
And when you divide that, it would be negative 3. So my answer was n equals -3.
Perfect. That's excellent work.
Nicely done. Now, Wizion, while I've got you on the phone, let me ask you a question, because let's leave the problem right there.
Okay.
And it says -6.9 divided by 2.3. Why would a student come up with 3.3? Can you see how they might come up with 3.3?
Yeah, because in a normal problem, if there's no decimal, and if it was 69 and 2.3, and if you were to divide that, then like it would be 9 divided by 3 would be 3, and 6 divided by 2 would be 3.
Right, so that's how a student might see 3.3. But even if we took the decimals out of there and we went 69 divided by 23, we'd still get 3, and you did well with the negative symbol on there. Now, because I know there are some students that are going to see that, and there are some students confused on that because of the decimals, and then you
Right.
get a whole number at the end. How do you know that's the right answer? Because you and Susie both agreed with all of your steps, but how do you know that's correct?
Because,
Is there a way to find out?
yes, since there's 2.3, I like to think of it like that's a whole. I made that mistake once, and then when I redid it, I realized that this was the case. I like to think of it as a whole, and that 2.3 goes into 6.9 this many times.
Good.
All
And
right,
we
so
could
you can
also-
verify that.
Yeah, we can also check it by multiplying. 3 times 3 is 9. 3 times 2 is 6. And since there's one decimal place, we need one decimal place here. And we have a negative times a positive. And so that would give us -6.9.
There you go. Nicely done, Izzion, for such a wonderful problem right there. We are going to send you to the movies, courtesy of our friends at Maya Cinema. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. Speaking of decimals, let's go ahead and take a look at the graphic that I've got underneath the camera here. And the question was posed to, I think it was about 2,500 people answered this online. The type of fun-sized candy, and how did it do against the rest of the candies that were presented
if you
to them?
agree,
So we can
which one do
see
you
that
like the
number
best?
one was a regular Reese's peanut butter cup, which came out to be 84.2%. The Reese's miniatures, second place. Twix, and I think, was it you girls behind the camera asking me if it was left or right Twix that I preferred, and wasn't quite sure where they were going with that, but I guess it's a commercial or something where they are trying to see if you prefer the left or the right side of the Twix. So Aaron and Grace are letting us know all the new things with the candy. Anyway, Snickers. I really would have thought that Snickers would have been a little bit higher on this list, but it comes in number 5. And wasn't surprised by the Reese's, and you can see the different ones right there. Usually we show the top 10, but it's like, all right, who was the one just underneath the top 10? So number 11 right there with the peanut M&Ms. And we can take a look at,
That's my favorite.
that's your favorite, the peanut M&Ms? There you go. So a lot of things with peanuts and peanut butter, even though there are seemingly an increasing number of kids with these peanut allergies.
Right.
These are still the most popular candies and ones that most kids will be receiving tonight. And I guess if you have the peanut allergies and you can't eat those things, your parents probably take care of those for you. Anyway, I wanted to bring that up because there are decimals in those numbers, and that's exactly what we're going to have Thomas working with right now. So Thomas, back to the board, young man. Let's get you back to work. So we know that you're good at multiplication, and you just worked on multiplying some fractions. So Thomas, choose a 2-digit number and go ahead and write it on the board.
Quickly.
11. All right, I'm going to choose 74. Yeah, there you go. That's the face I was looking for, not something simple. Like So, Susie, what we'd like to do now is we'd like to put some decimals in there somewhere. So I will allow you, whoa, hold on there, cowboy. Susie gets to place the decimals.
Okay. Right here and right there.
So now we need to multiply those two numbers.
Okay. Good, that's a good start. Now, we probably don't want to write them across. So you could put one of them underneath, okay? Okay. So, okay. Right, so what are you going to do first? Don't worry about the decimals yet.
4 times 11 equals 44.
Okay.
But if that's 100 and this is a tenth, and this would be a 40. So 40 times 11?
Well, we're going to do the decimals at the end. So just get we got the numbers on there. We'll worry about the decimals at the end, but that's good thinking. You're always already worried about that. Okay, and now the next row, you're going to need a placeholder. Wait a second. Let's take this off, okay? And now you're going to multiply by the 7. Okay, we need to start over. Just a second. All right, so I'm going to line it up a little bit better. Okay, now I want you to pretend that the decimals are not there and just do it like the decimals are not there. 4 times 1 is 4. 4 times 1 is 4. Okay, like you already did this part. And then a placeholder. Yeah, now you know what to do. Seven times 1.
I know.
Okay. Good. It's okay. We know it's an 8. And 0. Okay, now let me show you something. Okay, how many decimal places do we have in the problem? We have
2.
1, 2, and
Wait.
1 here. So we have 3 numbers that are
Oh, yeah.
behind the decimal point. So we start here and we go 1, 2, 3, wait a minute, and it goes here. You have to go backwards.
The number of decimal
Yeah,
things?
1, 2, 3.
And you go back that
1,
many
2,
times?
3, exactly.
Okay.
Good.
Ah.
That's good enough. We're having trouble with the pens today. Okay, 0.814.
All right, so Thomas, I'm going to throw this one at you. How can you read that number
Oops, I won't.
other than saying 0.814? Do you know how to say that with the place values?
0.804 thousandths.
814
Oh.
thousandths, right?
Oh, I didn't see the 1.
There you go,
Yeah.
because the 8 will be the tenths, the 1's in the hundredths, and the 4 in the thousands, so 814 thousandths.
Now, at the beginning, you noticed that this was 11 hundredths, and this was 7 and 4 tenths. Let me show you where the thousandths came from. Just a second. 100 times 10 is 1,000. Do you see that? Okay.
There you go. Nicely done. We'll get some more work on decimals in a little bit. We do have phone tutors available until 5:30. We'll be heading back out to Franklin in a little while. We'll do it all right after this.
Put it back.
We're in California City at Hacienda Elementary School, and today we're here to We're at Hacienda Elementary School. I've got Jacob with me. How are you?
Good.
You ready to roll?
Yes.
Let's go. Mean, median, mode. Have you ever seen those words before?
Yes.
Long time ago?
Yeah.
Okay. So that's why we're going to go over this, because there's some students that have never seen this before, and kind of a little refresher for you at the same time.
Yeah.
So mean is the average of the numbers. The median will be the number in the middle. If you're going down the street, the median is in the middle of it. And the mode is the number that comes up the most often. So what we'll do first is we're going to do the mean. So the mean, we're going to add the numbers. All right, if I had 3 plus 5, what does that equal?
8.
8. And then I'm going to divide that by how many numbers there are. How many are there?
2.
So what is 8 divided by 2?
4.
So the mean, the average of 3 and 5,
Is
is
4.
4. Okay?
Okay.
So let's go ahead and get rid of that. Now I did the hard part. You get the easy part. You need to find the average of all those numbers. So what do you think
Okay.
you have to do?
I have to add them by two certain numbers.
Add them all up. So add all of them.
Wait, all of them together?
Oh, you got it, brother, all of them. And you can do it any way you want.
Okay.
You can use the eraser there, too.
Okay.
All right. So as you're doing this, if you can, explain to me what you're doing as you're doing it in your head, maybe. Explain to me what you're doing, all right? Go.
I'm adding two numbers at a time.
Okay. So what are you going to start with?
4 and 4.
Okay.
8. Then I'm going to just put this over here.
Okay.
Then I'm just going to do it like how I was. Then I'm going to add these together.
Okay.
So,
All right, so you got 77. Nice job of taking numbers and adding them together, putting them off on a side, a little bit easier for you that way, right?
yes.
Okay. So we know that all of these will come out to equal 77. But now, is that the average, or we still need to do something else?
We still need to do something else.
What do we have to do?
Divided by how many numbers?
And how many numbers are there?
7.
Okay, so put your fraction bar, divide by 7. And you know what 77 divided by 7 is?
Yes, 11.
That's an easy one, isn't it?
Yeah.
Okay. So the mean, the average of all these numbers is what?
So, 11.
11. So we'll put it right up there. Okay. The median is the number in the middle. So we're through with this. So now we want the number in the middle. Okay. So here's an example. If I had 1, 2, 3, 4, 5, what number is in the middle?
3.
3, because I take one off the front, one off the back. One off the front, one off the back. The number left in the middle is 3. Okay? And there's a thing to do if there's 2 numbers left in the middle, but we'll see if we have to do that here. Now, the first thing you want to do is you want to make sure all the numbers are in order. Are these numbers all in order?
No,
No, they're mixed up a little bit here, right?
just 2 numbers.
Okay, so rewrite them down here in order for me. All right, so we've got 4, 4, 8, 11, 12, 16, and 22. We still have 1, 2, 3, 4, 5, 6, 7 numbers. Good. So which one's in the middle?
11.
Okay. Can you show me how you got to 11?
I know because odd numbers always also have a middle.
There you go. Perfect. So above median, what was the median?
11.
So go ahead and write it up there. And you remember what the mode is?
No.
The number, okay, think about mode, most often.
Oh,
Most often, all right? So is there a number that shows up more often than any other number?
11.
How many 11s do you see?
Oh, I know. 4, I mean.
How many 4s do you see?
2.
Are you sure you want to go with 4?
Yeah.
All right. So go ahead and put the mode of 4. Jacob, you have mastered mean, median, and mode. Good work. And once again, a big thanks to all of the staff and students out at Hacienda Elementary School. We had a great day out there. We do have phone tutors available until 5:30. We'll put Thomas back to work in a little bit, but right now we're going to go out one more time to Franklin Elementary and visit with Devin.
Hey, thanks a lot, Mike. Back at Franklin Elementary School, joined by Ava right now. And when we last left, we were looking at ways to make sense of $1 million. And I gotta say, I'm really impressed with a lot of the work that the kids here did in representing what $1 million truly looks like. I want to start off over here with showing some of the ways that this is the group that started with the ones place to the left. And what I appreciate is that we didn't cross it out and start over. We stuck with it to see if we can continue that relationship, because what I think it lets us do is really show how many of each place value makes $1 million. So what this group did is they started with the 1 million, because 1 million equals 1 million. One group of $1 million is 1 million. And then we said 10 groups of 100,000 equal $1 million as well. And this pattern continued. One of the realizations that a lot of the kids here noticed was that $1 million is 1,000 thousands and 100,000 tens. And a lot of these connections were really powerful. What I liked out of this group too, what you guys did, which is really interesting, is you showed the relationship between all the place values. So the idea that 10 of this is worth 1 of the next one over to the left. So 10 ones is the same as 1 tens, or 10 hundreds is the same as 1,000. And they made that connection in this column with the arrows. I thought that was a really interesting connection. I'd like to bring you over to one more group who took a little further. So much further that they needed extra paper, because they did the same thing but then realized, hey, place value tables don't have to end at ones. They went into the decimal zone. So we realized that $1 million is 100,000 tens and 1 million ones, but also 10 million tenths. And what did you notice as you went further into the place value zone, into the decimals?
That we were adding 10 onto them each time as we went down.
So you had a multiple of 10 every time you went further to the right on the place value table.
Yes.
So, I mean, that's a really big connection as far as place value that this group is making. That when you go 10 and you move over 1 place value to the left, the value goes up by 10. But when you go to the right by 1 place value, your value goes down as you divide it by 10. So we're talking about $1 million. And I like making sense of $1 million, so I wanted to see if I could ask you guys a question, because it's such a nice day. It's a really nice day here in Bakersfield. Do you think you could run 1 million centimeters?
Yes.
Does that sound exciting? We have some. Let's get a show of hands. Thumbs up if you could run 1 million centimeters. Thumbs down if you want to let somebody else do that. Okay. Well, what are your thoughts on that? Ava, first I want to get your thoughts. Do you think you could run 1 million centimeters?
Yes.
Why do you say yes?
Because centimeters are tiny.
Centimeters are small, so even if you had 1 million of them, you don't think that it'd really be all that much, right? Is there anybody who says no? I saw a couple of no's for that. Everybody feels good about running 1 million centimeters. So I want to see if we can kind of get some reference here, because we're going to give this a shot in our next segment here. But I want to kind of let you guys know a little bit what you're in for. So this ruler, if you take a look, it's a standard foot long, but it has 30 centimeters on it, right?
Right.
So one of these, could you guys take your pinky and kind of point that up here a little bit? Your pinky? This is 1 centimeter wide. Your pinky is 1 centimeter wide. It's a great standard here, okay? Now we know that 100 pinkies is 1 meter. Now your school track out here is about 400 meters long. So how many centimeters do you think that would be? Or how would he figure out how many centimeters long 1 lap is? What do you think we would do? What would we have to do on that? How can we find out how many centimeters are in 400 meters?
By adding?
Yeah, we'd have to add 400 100 times, or 100
Times
400.
40.
Or we could just multiply, right? So we can do 100 times 40. I'm sorry, 400. And well, one of the nice things about multiplying by factors of 100 is that we can just multiply the initial values and then add the zeros. So we can start 1 times 4.
1 times 4 is 4.
And now how many zeros do we have here?
4.
So 3, 4. Should we throw any commas in here?
Right.
Right there. So what is this number?
40,000.
So that means there's 40,000 centimeters in one lap. So we're going to figure out how many of those laps it's going to take, and I can see Ava's face right now when she's starting to piece together this. How many groups of 40,000 we're going to need to get to 1 million? Well, we're going to work on those numbers here. When we come back, we're going to hit the track and have a deeper conversation about 1 million centimeters. Mike, back to you in the studio.
All right, thanks for that. Glad Ava didn't ask you to start running 1 million centimeters right now and get started on that. Anyway, we have got a couple of moments. Let's get Thomas back to work. Over to the board, young man. I'll put this number up. 1963.
Wait, is that a year?
Yes? And put a decimal between the 9 and the 6. Susie, choose either a 2 or 3 digit number he'll have to multiply that with.
Please be two.
Okay. Okay, so where are you going to start?
4 times 3 equals 12.
Good.
4 times 6 equals 24 plus 1.
Wait, got to put it up there.
Oh,
Okay.
2. And then placeholder.
Wait. You have to finish doing all of these.
Oh, all of them. I thought
Yeah.
only the ones after the. I'm not even
Your
touching
arm
the
is
board.
hitting the board at the same time is
Okay.
what that was.
Okay, so yeah, just pretend the decimals aren't there and do the multiplication. Okay?
4 times 9 equals 36 plus 2.
That's right.
4 times 1, obviously.
Okay.
The big number.
Okay, and now we're gonna.
Place.
Exactly. Don't worry about it. We'll worry about it later. Okay? So 2 times 3.
2 times 3, 6. 2 times 6, 12.
Whoops. You're trying to. Yeah, you have to. Want me to erase these? Good. Okay, you got it.
Yeah, I'm getting confused by them.
Mm-hmm. And 2 times 9.
Oh, yes. 2 times 9 equals 18.
Plus 1. Plus 1.
Plus
We got a 1 here. It's
1.
just, remember, it's
Oh.
up there, okay? All right, so 2 times 9 is 18,
19.
plus 1 is 19. Okay,
And then 2 times 1 equals 2 plus 1.
okay, but this, remember, okay, now. So you gotta be careful because
move
the
this down a
7,
little
9
for you
goes
here.
with the 9. Okay, we don't have to write it again. Okay,
I
so,
want to. It'll confuse
all right.
me later.
okay, good. Okay, now you can add them up. And don't worry about the extra, the dots.
2,
Mm-hmm.
11, 17,
Mm-hmm.
4.
Okay. All right, now, before we put the comma in, we need to count the decimal places. The numbers, how many
1,
numbers?
2, 3.
That's right.
1, 2, 3.
Perfect. Yeah, we got it.
Now read that number.
47.112 thousandths.
Good.
good.
And instead of saying point, you can always say and.
Oh.
So say 47 and 112 thousandths. There you go. Nicely done.
Thank
Hey,
you.
you know what? We
Okay.
do have phone tutors available until 5:30 this evening. And Friday, it was a big day for our friends at Castle Elementary in Bakersfield. An official name change, big things going on over there, and a new way of learning for the students at Castle. Our cameras are there to capture the festivities and excitement at the new Castle STEAM Academy.
Oh.
here to celebrate the grand reopening of Castle. We are now Charles H. Castle STEAM Academy. STEAM stands for Science, Technology, Engineering, Art, and Math. And our program infuses STEAM throughout labs. It's hands-on, inquiry-based learning experiences. And then we also use STEAM elements in our curriculum in the core classroom. So students get hands-on, interesting learning experiences that also connect to the sciences. And that prepares them for college and career in the future as well.
It's doing new things, and with that you need the money, and we tap the resources at the Kern County Superintendent of Schools who are experts in grant writing. We lifted people from the classroom, we drove the grant from here to Sacramento and hand delivered it. We're going to invent a model that can sustain beyond the 5 years that the grant is, so that it can go on year after year.
There was a certain chemical in it, so scientists were able to go in and find out with that chemical what happened.
It is a very different approach, and it's definitely a paradigm shift. So educators take more of a role as a facilitator and a guide. They look at setting up quality activities, posing novel problems, and giving kids the skills to be able to solve the problems on their own. And by doing that, students understand what they're learning and internalize concepts much better than just rote memorization and that sit and get that we've seen traditionally.
The brain works in very unique ways, and we're finding out in education, and we're implementing here very different seating, very different walls, very different projections, TVs, everything, even the audio has been specifically designed for what we know in learning.
All right, pretty exciting things going on over at the Castle STEAM Academy, and I know that the Kern County Q Conference was held there just a week or two ago, so a lot of educators throughout Kern County and elsewhere were able to experience some of the very neat and cool things. A lot of technology put into those rooms, and very exciting for the Castle STEAM Academy students. We do have phone tutors available until 5:30, and right now we're going to go back to the board, and Thomas, time for you to get to work. We're going to take a look. We've already done problem number 5 on this paper, so we'll go ahead and look at number 6. Mikos and Dave have a total of 49 toys. If Mikos has 5 more toys than Dave, how many toys does each one of them have? So we have Mikos and Dave. You can just go in M and a D if you want later on. Total of 49. Mikos has 5 more than Dave. We need to know how much or how many each of them have.
So you had a good way to start, what you whispered to me over there. How did you want to start?
You could split that in half, or what's closest, which is 25 and 24. And then you
so let's put a plus. I did it again. I touched the board. Can you get it back?
Sure, we'll just undo right there.
Okay, all right.
And then you could subtract 5 from 1 and add 5
to the other.
And then this.
So now they're 9 apart, and you want them to be 5 apart.
Oh, yeah.
Here they were 1 apart, and here they're 9 apart. But you do have 49, so what could be like, try to guess and check a few between there. Like,
Subtract 4 from this, add 4 to that.
okay, you can try that.
So 25 and 24. That's what I got there, though.
Okay, so what's between 20 and 24? Exactly right in between 20 and 24.
2.5. 22.5.
Right, just 22.
Oh.
22. Okay.
23? Oh, wait, no.
Here, hold on a second. Let me get that
Okay.
off.
All right. So this one's 2 more.
27.
Right, try that.
Yeah, there.
Hey,
Final
it
answer.
worked. It worked.
All right, there you go, 22 and 27 by guess and check. Now, Susie, do you have another way that you can solve that without randomly throwing numbers out there?
Yep. Here. Sorry. Let me use the black one, okay? So I'm going to use M for Mikos. So M plus D equals 49. Now, I know that, what does it say? Mikos has 5 more than Dave?
Mikos has 5 more.
So instead of Mikos, Thomas, I'm going to put Dave plus 5 because Mikos is Dave plus 5. Does that make sense? Okay, and then I'll put them together. All right. Now, do you remember how you were talking about the K's before? Okay, I can put, if I have a D here and I have a D here, that means I have 2 D's. Does that make sense? And then I have 5 1s and I get 49. Now, this is kind of like a teeter-totter. You haven't done equations yet, have you? But do you see how this is equal? Okay. If I want it to stay equal, I have to add the same thing to both sides or subtract the same thing from both sides. So I'm going to subtract 5 from this side and from that side. And I'm going to move over here. Now, plus 5 minus 5, what's that? If you add 5 and subtract 5.
0.
Right. So so now I have 2 D's is equal to 49 minus 5. What's 49 minus 5?
44.
Right. Okay. Now, if 2 D's is 44, what do you think 1 D is?
22.
Right.
And that's
okay. And there it is. There you go.
And then you just subtract that from 49, and that's Mikos.
That's right. That's right.
There you go. Nicely done. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget the 5th grade call-in contest starts today and will run throughout the entire month of November. The 5th grade class that calls in the most during the month will be, awarded a visit from Do the Math. We'll send some folks out there with some prizes and some different math games and things like that. So 5th graders, do make sure that you call in and give us your instructor's name when you phone in, so that way we can differentiate between the different classes if you're calling from the same school. How heavy do you think the heaviest pumpkin
well, I have
has
to
been?
admit
Heavy,
that
heavy as a car.
I was kind of peeking, and I think it was like in the 2,000 range or something
Right, so
like that.
we've got a graphic right here, 2,625 pounds.
And
So
how
there
did they
we go.
move it?
Well, I don't know. Experts take care of that. But anyway, as heavy as a car right there. And we'll go out one final time to Franklin Elementary and visit with Devin.
Hey, thanks a lot, Mike. Hey, I asked for it, and these folks here at Franklin are more than willing to go through the 1,000,000-centimeter challenge. I didn't think they would. I don't know if there's any liability that we have to qualify ourselves on, but we're going to go for it here. They said they think they could run 1,000,000 centimeters, and we've got a bunch of willing participants ready to go. Ladies and gentlemen, are you ready for the 1,000,000-centimeter challenge? Yeah! On the count of 3. 1, 2, 3. I'm here with Jemiah now. Jemiah, real talk. The 1,000,000-centimeter challenge is, I think, a little more than they thought it would be, right? So when we had that conversation, we took out a little ruler and we said, like, okay, this is 1 centimeter. Do you think you could run 1,000,000 of these? And everybody said, yeah, sure, no problem. Yeah, we could do it. And then right away, you started doing some of the math on this. So I wanted to kind of talk a little bit about your process on how you perceive this as the 1,000,000-centimeter challenge proceeds. So we started off by saying, okay, you knew that 1 lap was going to be 400 meters.
Yeah.
So then what did you do next?
I added 400 plus 400 for 2 laps. So that gave me 800. Then I did the rest for all of the other laps.
Yeah. So what you can end up doing, too, is you realize that we weren't really looking for 1,000,000 centimeters here. We were looking for 10,000 meters. And so what we started to do then is realize, hey, maybe I can scale up and multiply. So we realized that 1 lap was 40,000 centimeters, which means that 5 laps would be 200 centimeters, which means that 25 laps is going to be 1,000,000 centimeters. So before they agreed to do this, they didn't realize that they'd be running 25 laps. It looks like we're through the first one. We already got some walkers. The 1,000,000 centimeter challenge is still underway. And they're going to be going for quite some time, ladies and gentlemen. I don't know if the school's going to be open this late. I think we can cut them some slack here. But what does that really say about how big 1,000,000 is to you?
It's pretty big because I won't be able to do that.
We'll give you a
It'll
break
take
in
you
the
like a
meantime.
long time to count to 1,000,000 and do 1,000,000 things. It'll take you a pretty long time to do. So 1,000,000 is a big number.
Even if you have a small amount like a centimeter, 1,000,000 of those grows pretty big pretty quickly, right? So what does that say about a number like 1,000,000,000, which ends up being something like 1,000 millions? What does that mean to you?
It's bigger.
It gets even bigger. I mean, we start to run out of words to talk about how big these larger values get. So let's think about that on the opposite direction. Your group started looking at the decimal values, and you started going smaller and smaller and smaller. If numbers in place value can grow bigger and bigger very, very quickly, what does it say as you go further into the decimal zone?
It'll tell you that it's getting lower and lower.
Like so small that we can't even really process what that means, right? We have to
Yeah.
find ways of expressing that. When we think about the width of one piece of hair, we're talking about maybe 1,000th of an inch at some points. And so if we think about how big an inch is, maybe the size, maybe the length of a thumb, right? And don't worry about the Band-Aid. It was not a good day cooking. But if we think about breaking this into 1,000 pieces, one of those is as wide as a piece of hair. And so we can go smaller and smaller. Really zooming in on that thumb there. I don't know if I'm comfortable with this there. But I want to thank everybody here at Franklin for really getting into big numbers like 1,000,000 and really taking ownership of that. Whoa, this is not going well, ladies and gentlemen. We already have walks about 80,000 centimeters in. And
I think I can do it faster.
you want to give it a shot?
Yeah.
Jemiah's going to go for the 1,000,000 centimeter challenge. On your mark, I'll count to one small piece of 1,000,000. 3, 2, 1, go! Oh. The ambition of youth is something I admire and envy. Maybe not right now, though. For now, we're going to send it right back to the studio, and we'll inform you if we do lock the doors before this challenge is complete. I think we're going to send these kids home. It's Halloween. They've got better things to do. Mike, back to you in the studio.
All right, thanks for that, Devin. You know what? I'm sure between what they're doing now and later on this evening, they'll probably get that 1,000,000 centimeters in right there. Anyway, we thank Thomas for coming in from Hart Elementary today, once again, to do a little math with us, work on some multiplying of decimals and things like that. One final duty for this afternoon. Need to pick a winner to attend a CSUB athletic event of their choice. The student will receive 2 tickets to any CSUB athletic event. So, Thomas, why don't you go ahead and reach in there and pull one of these out? And who is that? Jemiah, there we go, 6th grader from Franklin Elementary, the girl that was right there and getting ready to run the 1,000,000 centimeters. So congratulations to Jemiah and all of the other students that phoned in today and did a little bit of math. Until we meet again, happy Halloween and continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.